Hey everyone, I'm Devesh and this is Kestrel. We have seen incredible growth in decentralized physical infrastructure lately. Think satellite networks, 5G hotspot, and global compute. But there's a massive capital problem hidden underneath. That's why we built Kestrel. We are creating the credit layer for the DePIN era, starting right here on Creditcoin. If you want to run a Spacecoin ground station or a high-end compute node, you're looking at anywhere from $3 to $50,000 in upfront hardware cost. Even if you're already an operator earning steady rewards, you can't actually use those rewards to get a loan for your next 10 nodes. In the DeFi world today, if you want to borrow money, you have to lock up 150% of that loan in volatile crypto. And it's a paradox to get capital to grow your business. You already need to be rich in crypto, and this capital gap single handedly slowing down the global rollout of decentralized hardware. And this is where Kestrel changes the game. We use Creditcoin's native query verifier to look across chains and prove your rewards are real. It's essentially an automated cryptographic pay stub. Instead of needing $10,000 in collateral to borrow $5,000, Kestrel allows you to borrow against your proven performance. We verify your last 90 days rewards, and if the data checks out, the protocol disperses the loan. And the best part is that it's self-servicing. A portion of your future rewards is automatically redirected to your vault until the debit. It's seamless, uncollateralized, and built specifically for node operators. So let's talk about the technical architecture of Kestrel. The system coordinates mainly with the three layers. First, we have the source layer like Sepolia or CC3 Creditcoin, where the actual rewards event are triggered. Second, we have our Oracle worker, which is a dedicated process that monitors these events and retrieves the necessary Merkle and continuity proof. The third layer, which is the Creditcoin's USC execution chain, is where the verification happens. Our revenue USC contract passes those proof directly to the third layer is where the verification happens, which is the USC execution chain. Our revenue USC contract passes those proof directly to the native query verifier precompiled. This allows the blockchain itself to cryptographically confirm the reward data from the source chain within a single block. By removing the need for third-party bridges or external price oracles, we have created a closed loop. The lender vault manages liquidity, and the revenue escrow ensures that a set percentage of every verified reward is used to service the loan before it ever reaches the borrower's wallet. Alright, so now let's see the demo of Kestrel. Let's go to the dashboard. This is the main dashboard, which shows all the capital allocation and the borrowed loans, active loans. Now Kestrel has two main actors. First is the lenders and the borrowers. Lenders are the liquidity providers. They deposit CTC into our automated vault to earn yield. But unlike typical DeFi where yield comes from speculative trading, here it comes from real world interest paid by the hardware operators. And now I'm going to deposit some WCTC, which is our wrap token for the platform, into the vault. Okay, so it has been approved, and now let's deposit the money into the vault. So it's confirmed and the vault has been updated with the new balance. Let's see this on Explorer. So as you can see, 14 seconds ago the transaction was done, and now I'm eligible for the yield generated by the platform. Let's go to the borrower. So this is the borrower page, which I'm going to change my wallet to a borrower wallet. Here I can apply for loan. So one thing you can see here is I have created this tool which is a simulate reward claim, and now normally this reward event comes directly from the node itself, like a Spacecoin node operator or Helium hotspot when it performs work. For this demo I'm using this button, and this trigger the oracle on a CC3 so we can see the data pipeline in action. I'm just going to claim a reward. Once the transaction is approved, Oracle will fetch that data. You can see it has started fetching, and now you can see I have 4 rewards being claimed. Once the borrower has 3 rewards incoming, the borrower becomes eligible for the loan. Okay, so approval is done, and now I can apply for the loan. Okay, so now I have an active loan approved. Let's verify this on the Explorer. You can see the loan is approved here. So this is the principal amount and this is the accrued interest. So the loan will automatically be repaid on every reward claim which happens on the CC3, and we can also pay manually. So let's pay all the amount manually. Okay, so the whole loan has been repaid. See this in the overview. I have 0 active loans now. Let's see this on the Explorer. As you can see, the loan transaction was confirmed here. Yeah, so this was all in the demo. So this is where we are now in our roadmap. Currently, our MVP is live on both the Creditcoin CC3 and USC testnet V2. We have successfully verified the entire flow from claiming a reward on the source chain to disbursing a loan on the execution chain. And our priority for Q2 is a formal security audit of our smart contract and then followed by a mainnet launch. Beyond that, we are focused on scale. We are building a modular adapter system so that any DePIN network, whether it's wireless hotspots or compute clusters, can integrate with Kestrel by simply pointing us to their on-chain reward events. So yeah, this was it about Kestrel. I really enjoyed working on the Creditcoin. Their docs are really intuitive and easy to follow through. Thank you.